In this lesson, we will learn about random number generation. What is meant by a random number? A variable, for example, x equal to 5 means x is having the value 5. But there can be a case that we assign a random value to x, meaning that the program will assign some random value to it. And each time we run the code, a random value will be assigned. Why do we need to assign a random value to a variable? Well, there can be a few reasons, and the simplest is different gaming applications. For example, rolling a 6-sided dice must return a random value from 1 to 6. In different RPG games, different collectible items are placed randomly in the map, and the players get spawned at different random locations inside the map. Other than game-like applications, there can be many other cases. For example, in robot navigation scenario or maze-solving cases, maybe there are more than one possibilities to select the next move, and in some algorithms that is to be selected randomly. So in computer science field, generating a random number is often needed, and there are different algorithms to generate a random number. What is the opposite of a random variable? The opposite of random is called as deterministic, which means something whose values can be determined. So what would be inside the algorithm of random number generator? There might be some complex formula, may be dependent on the present time of execution of that algorithm, and hence giving hopefully a different number each time. But still it cannot be a pure random number. So usually we use the term pseudo-random number generator for these generators because a true random number generation is hard to be realized. You can search for random number generation algorithms and you will find that there is always a discussion on actually truly random number generation. Even though we have pseudo-random number generators, but they are good enough for most of the applications. Enough said on the random numbers. Now let's see how we can generate these in Python. In Python, we have a built-in module named as random. So let's import that. Inside the random module, there is a function named as random, which is the same name as the module name. Let's see the help on this random function inside the random module. It says that it will generate a value in the interval from 0 to 1. 0 is included in that interval and 1 is not included. So let's generate 10 random numbers using the for loop. You can see all these numbers are random and all are between 0 and 1. If I run this code again or you run it on your system, you will see different values generated by this function. Now if we have to generate numbers in some different interval, let's say between 5 and 10, then we can apply some scaling and shifting on the random numbers generated by the random function, but we have another function for this purpose and that is named as uniform. In this function, we have to provide the starting and the ending value of the interval, and now you will see 10 numbers generated between 5 and 10. Basically, this uniform is a probability distribution function. If you are familiar with probability distributions, those can be of many types, and the module random has support for a few of those. You can find the detail by printing the help on random module if interested. This uniform distribution as well as the random function are continuous distributions, meaning that they can have any floating value between an interval. We can have possibility of discrete probability distributions as well, which simply means that it will be generating some random discrete number and those will be the integer values. For example, in case of rolling a dice, we need a random integer from 1 to 6. For that we have a function in the random module named as randint. And inside that we have to provide the interval which should be from 1 to 6 in case of a dice. Both provided values are included in that interval. So now if I will run this code, you can see random numbers from 1 to 6 are generated in each iteration of the for loop. So this program is a simulation of rolling a dice 10 times. Other than these functions in the random module, there are some other functions related to some other data types, for example for the list, and we will see those when we will study about those data types. So in the remaining part of this lesson, we will simply do the task which requires some random number generation. Now let's write a program of simple guessing game. Our program should generate a number randomly between 5 and 10 and the user will have to guess it until he guesses that correctly. So I'm printing a simple message. Now I'm generating a random integer between 5 and 10. Now I'm taking a number from the user as his guessed value. Now I can have a very simple condition that if the guessed value by the user is not equal to the random number generated by the program, I will print something like your guess is wrong. And then I can ask him to guess the number again. Now again I should check if the new guess is correct or not. So basically instead of the if statement on line number 5, I should use a while loop so that this process will continue until user guesses the number correctly. This while loop will terminate when the value of n will be equal to the x, which means the guess is correct. So outside the while loop I can print that your guess is correct. Let's run the code. I really don't know what number is generated by the program. I will guess it as 6 and that is wrong. Now I will guess again. Let's say 7 and this time it is correct. An important thing in this program is that this generation of the random number should be outside the while loop. If you will do it inside the while loop, every time a new random number will be generated and that doesn't look appropriate. Because when 6 was displayed as a wrong guess, I will never enter the 6 again. So this random number generation should be outside the while loop so that the random number is generated once and during the iterations of the while loop, that number is not changed. Now let's say we also want to print the number of tries user has taken to guess the correct number. I will declare a count variable, for example trial, and I should initialize it to 1. I will not initialize it to 0 because on line number 4 I have taken one guess from the user, which is his first trial, and if that would be true, there won't be any iteration of the while loop. And now inside the while loop I should increment the variable trial by 1 in each iteration of the while loop, and now outside the while loop I can also display the number of trials taken by the user. I think we can also do it using the infinite while loop and using the break statement inside that. Anyways, let's run this code. I will guess the number as 6 and that is correct in the first trial. So I just took one trial to guess the number correctly. Now let's run it one more time and this time I will guess the number, let's say as 7, and it is again correct. Trust me, I'm not playing with you. I had no idea that I'm so lucky in guessing the numbers. I'll have to run it one more time and this time I really wish my guess is wrong. I will guess it like 8 and it is wrong. So I will guess again. Let's say 7 and it is wrong again. Now I will guess it as 9 and again it is wrong. Let's guess it as 10 and this time it is correct. And you can see it displays the correct message that you took 4 tries to guess it correctly. Now let's say if you have to increase the range of numbers, for example from 0 to 100 instead of 5 to 10. So I can very easily do it over here. And this time it will not be easy to guess the number. But what I want in my program is that when the guess of the user will be wrong, then our program should indicate that the generated number is above the guess or below the guess. So it will help the user to reach to the guess easily. So we can do this inside the while loop. So if the guessed value is greater than the number generated by the program, we will display that the number generated by the program is below that guess. And similarly, if the guess is less than the value generated by the program, we will display that it is above that value. We don't need this print statement now. Let's run the code. A number is generated between 0 and 100, so let's guess it as 20. We got a message that it is above that. So I will guess something more than 20, let's say 30. And still it is above that. Now I will guess it as 60 and it is still above that. Let's guess it as 80 and it is still above that. So let's guess it as 90. What's happening? It is still above that. So now let's make it as 95 and surprisingly it is still above that. So let's go for 99. Thanks God it is now below that. Now let's guess it as 97 and now it is correct. And we took 8 trials to guess the number correctly. Usually when we write this kind of program, for the testing purpose we can print the value of the random number generated like that, and once we have tested it and the logic is correct, we can remove that from there. Now if you see the lab manual, we have done the first 2 tasks. And now this task number 3 says that we have to write a program which will simulate the roll of 2 dice. Sorry, I have written over there that dice are tossed, but actually it's a coin which is tossed. The dice are rolled. So anyways, 2 regular dice are rolled and the sum of the output is noted. And we have to repeat this n number of times. And if the sum of the outputs of the 2 dice is greater than 7 for more than 50% of the trials, the user will be the winner, and if not, he will be the loser. We will first ask the user to enter the number of trials, and then the program will have that number of rolls, and finally will print if the user is winner or not. So let's write the program over here. First, I will ask the user for the number of trials. And then I should use a for loop for that number of trials. And inside the for loop, I can first display the trial number. And then I have to generate a random integer between 1 and 6 for dice 1. And then for dice 2 as well. Please note that we are generating these random integers inside the for loop this time, because for a new trial, there should be new random numbers on the dice. We have to check the condition if the sum of the output is greater than equal to 7 or not, and we have to count those number of rolls. So I can declare a count variable before the for loop, and then inside the for loop I can apply the condition, and then we'll increment the count variable. And now outside the for loop, first I can display how many times the sum was greater than equal to 7. And then I can apply the condition that it happened on more than 50% of the trials. So I will print that you won. And in else I can print that you lost. So this program will generate these numbers and will do the calculation, but it is not displaying anything on the trials. Let's first run this code. I will enter 10 trials. And you can see we have just the trial numbers and finally the end result. So we should actually display the output of the dice in each roll. I'm doing that over here. I should also display the sum of the output. So now let's run the code. I will again enter 10. And this time you can see different trials and also the output of the 2 dice on each of the trial. And finally the end result. But over here there is no much involvement of the user with the program. He is just entering the one number and then getting the end result. To get him involved in the program a little bit, after each roll of the 2 dice, we can ask him to press some key from the keyboard to initiate the next roll. We will not do anything on the key entered by the user. It can be any key. The purpose is just to hold the program over there, and the next roll will occur when the user will press some key. It will be better to use getCharacter function so that the user does not need to press the enter key after the character he will enter. So let's do that over here. I'm just changing the dice number to Roman notation just to make it different from the output of the dice. And now to take any character from the user, I will import MSVCRT module. And then inside the for loop, I can take in one character from the user so that compiler will stop over there until user presses some key. I cannot have a customized message inside the getCharacter function like we can have inside the input function. So I will print some message before the getCharacter function using the simple print function. Now I will enter 5. You can see it's asking to press any key for the next trial. I have pressed a key and the trial 1 is shown over here. Dice 1 got 6, dice 2 got 6 and the sum is 12. Now it's asking to press any key for the next trial and again for the next trial and so on until the trials are completed. Now let's see the next task. It says that you have to write a simple quiz application for the kids to test their simple addition skill. So your program should generate 2 random numbers both between 1 to 15 and it will ask the user about the sum of those numbers. And it will display if user has added those numbers correctly or not. For example, the program will be displaying 9 plus 11, and if user enters 20, the program will display that it is correct. And of course, if it is not correct, it will display it as wrong. So let's write that over here. I have to generate two random numbers between 1 and 15. Now I have to display those numbers to the user, and I have to ask him the sum of those numbers. I can take the input from the user, and as the input message, I can use a formatted string, and I can use those randomly generated numbers A and B. So the user entered value will be stored in variable x. So now I can simply compare if x is equal to A plus B or not. Let's run the code. The randomly generated numbers are 15 and 14. The sum is 29. So if I'll enter it as 29, the program has displayed that it is correct. Now this time different numbers are generated, and the sum of 7 and 11 is 18, and if I enter is something like 10, it has displayed that it is wrong. So it is a simple quiz application, and in the next task, I have asked to generate the questions 10 times and then display the result that out of 10 how many questions were correct. So I can make these statements as a block of the for loop, so it will generate 10 random questions. But I should also have the count of the correct answers, so I can declare a count variable equal to 0, and if the answer entered by the user is correct, I can increment the count variable. And outside the for loop, I can display how many questions were correct. Let's run this code. I'm entering the correct sums. Now I have entered one wrong answer. You can see 9 out of 10 questions were correct. Now in the next task, I have said that with addition, there can be a question of subtraction or multiplication. And this operation, that is addition, subtraction or multiplication, should also be selected randomly. There can be some easy way of generating the operation randomly using some data type which we have not studied yet. So at present we can do it in a simple way that we can generate a number between 1 to 3 randomly, and then we can have 3 if statements. For example, if the number generated is 1, there should be the addition operation. If the number generated randomly is 2, there can be subtraction operation. And if the random number generated is 3, it can be for the multiplication operation. So I hope you can do this task easily. The next task in the lab manual is related to probability. I hope you are familiar with the basic concept of the probability. For example, in case of rolling a dice, what is the probability that 2 shows up on the roll? Theoretically, there are 6 possibilities, which is the sample space of this experiment, and the event that 2 shows up, of course, has only one possibility that 2 shows up on the output. So theoretically, the probability is 1 over 6 or 0.1666, and that will continue, or we can approximate it as 0.1667. There can be an experimental way of finding the probability, and that is by actually performing the experiment for, let's say, n number of times and then noting down that how many times 2 showed up on the output, and the probability of the event will be that number divided by n. So suppose the dice is rolled 30 times, and out of those 3 times 2 showed up, the probability will be 3 over 30 or 0.1. So is that correct or not? If instead of rolling the dice 30 times, if I only roll it 2 times and 2 shows up on one of those rolls, so the probability will be 1 over 2 or 0.5. So is that really correct? Or if 2 does not show up on any of the 2 rolls, then the probability will be 0 over 2, which is 0. So again, can we consider that as correct? Basically, there is one very important condition in the formula of this experimental calculation of the probability, and that is the limit on n approaches to infinity, meaning that we have to repeat the experiment to a value approaching to infinity. So let's see this task where 2 dice are rolled, and this table shows the sample space of that roll. We have 6 possibilities for the first dice and 6 possibilities for the second dice, and overall there will be 6 times 6, which is 36 possibilities. And if I have to find the probability that the output of the both dice is same, then these are the highlighted elements from the sample space which satisfy the condition. As you can see, these are 6 of those. So theoretically, the probability should be 6 by 36, which is 1 by 6 or 0.1667. Now we will do this experimentally by writing a program. I will generate a random number from 1 to 6 for the first dice. And of course for the second dice, I have to do it for n times, where n is the number of times I want to roll the dice. So let's take that value of n from the user, and then we will use the for loop to roll the dice n times. I will declare a count variable, and if the output of the two dice is same, I will increment the count variable. And then outside the for loop, I can print the probability of the event as count divided by n. Let's run the code. I will enter 5 as number of trials or experiments, and the probability is 0.2. Remember, the theoretical probability is 0.1667. This experimental probability is not close to that one. But now let's run the code again, and this time let's enter some bigger value, for example 100, and now the probability is 0.15. Now it is getting closer to 0.1667. Let's run the code again, and this time I will enter 500, and the probability is 0.178. Let's run it again, and let's now enter 5000, and the probability comes out to be 0.1604. You can see now it is quite close to the theoretical value. Let's run it one more time, and now I will enter 10,000 trials, and now the probability is 0.1643, which is very close to the theoretical value. Now let's run this one last time, and this time I will enter 500,000 trials, and the probability is nearly same as the theoretical value. So this confirms a very important thing, that the random number generated by random module of Python is very near to the true random number. Otherwise, we will not be getting the value closer to the theoretical value. Now I will discuss the review question. It is similar to the guessing game, but after the correct guess, user can rerun the code for the next game. So it will continue, and after the correct guess, user can have the next game. And this will continue until user enters something other than Y to end the game. This is very simple as we have done it previously, but after the user will end the game, you have to display some statistics of the game. For example, total number of games played by the user, total number of guesses for all those games, and then average guesses per game, which is simply the ratio of the previous two values. And then this last thing is a little tricky, where you have to display the best game. The best game is the game having the minimum number of guesses. Now how can you determine that? Listen the logic carefully. You can declare a variable, for example best equal to some big value, for example 500, because we know in any game the guesses will be less than 500 of course. And then at the end of each game, you can compare the guesses of that game with the best variable. If the guesses of that games are less than the best variable, you can update the best variable equal to these number of guesses. So eventually at the end of all games, the variable best will contain the minimum guesses taken by the user. So that's all from this lesson. Thanks for watching.